So in the previous video we started the VSEPR theory. We realized that electrons want to repel each other, and they do repel each other. Therefore the atoms the electrons are associated with are going to be in the longest distance from each other in space. As long, of course, as they are connected to the central atom and they are limited to move, to repel from each other. And the longest distance from different atoms is going to give us very specific structures that we are going to learn. The first structure I would like to recap from the previous video is the linear. The linear shape is when you have two bonding pairs and two valence electrons and no lone pairs. It means that if you have one central atom connected to two other central atoms, not central but connected to the central atoms, and no lone pairs of electrons in the middle, we are going to get something called linear. And it is called linear because the degree between the atoms is going to be 180 degrees. Now, the next one would be when you have three things attached to the central atom. When you have three things attached to the central atom, but still you have no lone pair of electrons, you are going to have the exact same distance from all of them. And because it completes to a circle, and circle is 360, we are going to divide 360 by 3, therefore we are going to have 180 degrees for each one. So three bonding pairs, three valence electrons, and no lone pairs, therefore equal division between the atoms. Let's go to the next one. What happens when you have four things connected to the central atom, like in methane? So when you have four things connected to the carbon, you are going to have something pretty interesting. You are still going to have the same distance from each other. So this one to this one is going to be 109.5. This one and this one is going to be 109.5. Again here, and here, and here between this one. Everywhere between the different atoms, the different three-dimensional structure, all of them are going to arrange in such way that we are going to have 109 degrees, 0.5 degrees from each other, which is exactly what you get, the degrees you get from each other. This shape is called tetrahedral. So you have some sort of 3D dimensional space structure that is going to resemble a tetrahedral. The next one is more interesting. The next one is starting to actually get a lone pair of electrons, and we brought it up in the previous lecture. The previous lecture we were only talking about no lone pair of electrons. But what happens when you actually have a lone pair of electrons instead of a covalent bond? So lone pair of electrons, just for the general knowledge, lone pair of electrons has more repulsion than an atom with electrons. So if you have a lone pair of electrons, you are going to have less and unequal division between the electrons and the distance between the different things. Let me explain what I just said. So let's take ammonia, for example. Ammonia, Lewis structure is as the following. We have a lone pair on ammonia. And this lone pair, everything it does is just to replace an atom that could connect to this place. So we do have four things to some extent that are connected to the nitrogen. We have actually three things that are actually connected, but we take into consideration the lone pair as well, which means that we are going to have also tetrahedral. But do we actually get a tetrahedral? Because this time we don't have the covalent bond. We have something else, and it is something that resembles the tetrahedral a lot, and it's going to be It's very similar to the tetrahedral, but instead of this atom, we are going to have a lone pair. So the shape is going to be very similar, as you can see. But this one is just going to be the lone pair of electrons. You're not going to have any atom. And this one is called Trigonal Pyramid. So it's called Trigonal Pyramid because it basically gives you the shape of a trigonal pyramid, a 3D shape of a pyramid. Because you don't have the fourth atom connected. You only have three things and one lone pair of electrons. But check it out. Now that we have a lone pair of electrons, we are not going to have 109.5 degrees. We are going to have 107 degrees because the lone pair is going to push and repel the other electrons stronger than what we could have over here. So we have a stronger repulsion of the lone pair of electrons. That's cool. Let's go to the next one. A very common example for the next one would be water. Water is the best example, and by the way, all of these are so high yield to memorize for the IMAT and BMAT exam, because usually when they give you some molecules to know the name of the shape of, they give you common molecules, and these are the highest yield molecules you can memorize. Of course, don't forget to check the link for the course, and I will give you the full list of all the highest yield, and also in the next episode, in the next lesson, I'm going to analyze even more structures. So water, let's draw first of all the Lewis structure. We have water in the middle, oxygen in the middle, and hydrogen on both sides. Now this hydrogen leaves us with two lone pair of electrons. And you will see that when we have two lone pair of electrons, the three-dimensional space structure that we are going to have is going to be as the following. We are going to have two, the hydrogen, and the oxygen. We are going to have the hydrogen, the lone pair of electrons attached to the oxygen. Now, why isn't water a linear molecule? Because we said already that when two molecules are attached to the center atom, it is basically going to be linear, no? So no. When you have one or two lone pair of electrons on the center atom, you are basically going to repel these atoms. You are going to have the force of the atom going to repel them as well. So instead of having a linear, now you have this electron pair that is going to repel them, they are going to push them down, like bending the molecule. Therefore, this shape is called bent shape. Now, because we have two lone pairs of electrons, and specifically for water, we are going to have 105, or in books it's 104.5 degrees between the different molecules. So it's going to be here 105 or 104.5 degrees distance, because the lone pair is going to repel them a lot and cause them to bend. Now, if we had a single lone pair, for example, it was a bit different. It's a different story. So we know that we have this trigonal planar, for example, which is 3 and 180 degrees between each other. But when you have a lone pair instead of this third atom, you're going to have around 116 degrees, which is not 180 and 20, but still it's less than 120 because the lone pair is going to repel the other atoms stronger than the actual atom that could be there instead of the three. And when we have this shape as well, it's a bent shape. The bent basically, it depends on the number of lone pair of electrons, and also it depends if it's water, because water is a specific molecule that is going to be even closer. The hydrogens are going to be even closer. So it's going to be 104.5, which is unique to water. So I just wanted to give you a list of structures that basically are going to pop up probably on the future exams, and they are very likely to pop up. In the next video, we are going to practice and see even more structures. And I'm going to remind you and to show you how to draw the Lewis structure using specific steps that are basically going to show you exactly immediately what is the lone pair, how many lone pairs you have, and what are the steps you need to do.